Okay, so for now we'll do this lab, okay, and after that we'll try to solve some questions based on the concepts that we learned in the previous session and in this lab. Okay, so this is okay. Srirang has joined. All right, this is energy forms and changes lab. Yeah, yeah. I have to make sure that I can also see the chat box. Okay, that is the reason why. You can actually zoom in on your screen. Okay, you can zoom into what is being transmitted to you guys. Yeah. If you have a mouse, you just scroll it back and forth. The scroll. If you have a scroll wheel on your mouse, you can simply scroll back and forth, and you can zoom in and out of the screen. Yeah. And make sure so this is a lab. We'll do this lab later on. There are two tabs here: intro tab and energy systems tab. Yeah, so first we'll do energy systems tab, so click on the energy system. um, so the first thing we'll do is basically make sure that the energy symbols are checked. Yeah, so we'll make sure the energy symbols, and it tells us different types of energies that are, so these are, you can see these are like energy packets. Okay, it is important to understand that energy is also in the form of packet. It is not something something that is vague or something like that. Energy is in the form of packets. Okay, and you learn more about this. There is a phenomenal theory on this actually was done by Einstein. Yeah, this is called as photoelectric effect, and you learn about the photoelectric effect. This was one theory that or the experiment, for example, that showed that the energy is in fact a packet. It's not something that you cannot understand. You can measure it, you can calculate it. It's pretty much like a matter. You can treat it as a matter. Okay. uh, so in a word, we say that energy, you probably have heard this: energy cannot be destroyed or created. Yes, do you guys know that? It can only be transformed from one source, from one form to the other form. All right, so that is the crux of today's lab. Basically, we'll see how the energy is transformed from one form to the other form. Okay. um, so in this experiment, there is a clock wheel. Yeah, and if this wheel rotates, then that is actually connected to a generator that will generate the energy. The energy will be transmitted to a heater. You can see there is a heater coil. Yeah, this heater will heat the water. Yeah, and if you heat it enough, you'll see the water boiling. All right, so what are the things that is going on? So what type of energy you would need? So you know the different forms of energy given right here. Okay, you have mechanical energy, you have electrical energy, thermal energy, light, and chemical. Yeah, so these are the different forms of energy that you can use, or interconvert into. All right, so what we'll do is this is a water tap. So this is something like, you see the hydro generators. For you pour the water from the dams and stuff, and you generate electricity. It is very similar to like that. Okay, so this is a tap, and you can increase or decrease the flow of water using this tap. Okay, there are different sources you can use. You can see the first one is a tap. Yeah, the second one is the sun, so you can use a solar light for the same purpose. The goal is essentially, the final goal is to heat the water. Okay, that is our goal. And there are different sources you can use to heat the water. There is also a kettle. You can boil the kettle. That will come out the steam can also rotate the clock wheel. Then there is a bicycle that can also be done. All right. So these are the two you can say units that will generate the energy. Okay, and so this will convert whatever energy is in here, will be converted by these things. So you have a solar panel, which is we were going to use that for sunlight. Yeah, and obviously you have a clock wheel, and then there are different outputs. You can either see it as a heating water, you can see it as a bulb, or light. Okay, everything clear so far? Yeah. All right, so every time we click reset, okay, so let me click a reset. So click a reset. Every time we click a reset, you will come back to this page. The first thing you will do is basically click on the energy symbols, okay, so you know the different forms of energy. All right, so let's start the water, and you'll see that the water come down, and what you'll see is basically, so you can see the water. I'll keep the flow slowly, okay, and you can see the energy is coming in the form of packet. Okay, some energy get lost, yeah, because the water is going down, getting lost. Some energy gets is used in in rotating this clock wheel, yeah. And as you can see, this is the mechanical energy that is coming from the water. It rotates the clock wheel. This is a mechanical energy. You can do it yourself. You can rotate by sitting there, or you can use water pressure to rotate the clock wheel. As the clock will rotate, it transforms the mechanical energy into electrical energy. You can see that the symbol changes from gray. So as it comes down, it changes into blue. Yes, it is. So you convert the mechanical energy, whatever the energy is captured by this particular clock wheel, gets converted into electrical energy. Yeah. And as the electrical energy is generated, it goes, it hits up an electric coil. Okay, it hits up the electric coil. You see that the electric coil has gotten red. Okay, let's do the reset again and see that before it is grayish in color, and as we rotate the wheel, you can see that the energy packets goes and hit the electrical energy, or hit the coil. Okay, as we hit the coil, you can see that more energy is added to the water. So this is getting there. It gets converted into thermal energy, yes, and that energy gets stored in the water up till certain point. Okay, it gets stored. You can see that the water is temperature is rising. Yes, temperature is rising, and it will rise up to a certain point, and at specific point, at specific temperature, you will see that the water is boiling. Okay, so what are the conversions? Is there a pause button? Yeah. So what are the conversions we are seeing here? We are seeing a mechanical energy getting converted into electrical energy, that gets converted into a thermal energy, and you see something happening to the water. It's not a reaction. Okay, it's just a boiling of water. So why does water boil? Basically, it has a specific it has a specific bondings. Obviously, as more energy is added to the water, these water molecules start to vibrate really fast, okay, in such a way that certain water molecules escape. Okay, and so you see that as a steam. These are the water molecules that has gained many energy, much more energy, and so they want to escape. They are breaking the bonds here. Is that clear? Yeah. So is that statement, the energy is constant in the universe, does it apply in this particular situation? Okay, can we say the energy is constant for the system? Absolutely, yes. Yeah, that's the universal law. Essentially, you shouldn't be doubting it. At least not now. Maybe when you are, scientist, or at the level of Einstein or something, you can disprove the theory, I guess. But I don't think you can. Okay, I don't think nobody can. It's a universal law. All right. But you can see that you can count the energy packets. Yes, some of the energies get lost, basically, with the flow of the water. You can use that for other purposes as well. It's not lost, it's just not getting used. Okay, but you can pretty much keep track of all the energy molecules, and some of the energy, you can see that it is getting stored in the water as thermal energy, to heat the water, and as the water reaches the boiling point, evaporation takes place. some of the heat energy, some of these energy packets get lost. You can see that. Yes, you can see that some of the energy packets get lost because what is happening here? The water is heating and heat dissipates into the environment. Yeah. Yes, the water is losing the heat to the environment. Water is losing the steam to the environment. Yes. Okay. You can keep track of every energy packets. You know, if you count them, you'll see that you can make sure you know, all the energy packets are accounted for. It's not generating. You know, these energy packets are not getting generated from anywhere. We are simply converting them from one form to the other form. All right. Exactly. Yes, that is the Arjun. That's the point I was actually going to make later on. But that's what we say. That's the latent heat, where the water gets converted from water to vapor. Okay. Now what happens basically if you so let's do that again, since Arjun brought it up. I think it's a very good question. It's a very good observation. So let's do that, and you can see that the water is absorbing energy. Yes, and it is, you can see that the energy rises. Yes, temperature is not energy, I'm sorry, the temperature rises. The water can store only energy that corresponds to its latent heat of vaporization. Yeah. So after certain point, so let's increase the flow and just boil the hell out of it. So, you know, lot of water, lot of flows, and you can see that energy. And after a certain point, it's pretty much constant. You don't see whatever energy you add gets, you know, out. Essentially, you know, the water starts to boil. You don't see the rise in temperature anymore. Okay. What happens? What is happening here? We're seeing a phase change. Yes, we're seeing that the water changes from water, liquid water, to gaseous state. Yes, this is the phase change. At the phase change, you don't see increase in temperature. It's the same thing with when you melt the ice. Yeah, up to 0%, sorry, not 0%, up to 0 degrees Celsius, you see that the ice is there. Yeah, you have a solid ice. At 0 degrees Celsius, it, you know, if it is losing heat, then it will become ice. If it is gaining heat, then if it is gaining energy, it will become water, but the temperature is still going to be 0. Is that clear? That is the concept of latent heat. Okay, so that is the reason why you don't see that the temperature is rising above 0 degrees Celsius, above 100 degrees Celsius for water. You know, the roughly boiling temperature of water is 100 degrees Celsius, and so you don't see that temperature rises above that. Is that clear? So whatever energy you add, you can see, you know, gets out essentially. You know, it basically, now it is dissipating more heat as we go. Yeah. All right, so let's steam. No, again, that's a different story. Steam actually, you know, if it cannot be 100, or it cannot be lower than 100, obviously in that case that would be water. Yeah, but the steam can be heated to very high temperature. Okay, it's up to you. You can heat it to, because remember that then after that there is no phase change. Yes, what if you increase the temperature of the steam to, let's say, 1500 degrees Celsius, what is going to happen? There is no phase change for steam. That is you can say that is the final phase. You know, after that you're basically breaking the bonds of the water. You'll have to, if you supply enough energy, enough heat, maybe the hydrogen and oxygen bond will break in the water, but after you know, it's not going to change to any other phase. Yes, so steam can be heated to a very high temperature. Okay, that is the reason why when you have you know, if you're standing, you have a pressure cooker, right? hot water is not as hot. You usually, you'll burn your hand, but the burn is not going to be a very easy. It's painful, yeah, obviously, but it's not as severe. But if you're standing next to a pressure cooker or something like that, and the steam comes onto you, you'll see that it is very, very hot. Okay, that's because the temperature of the steam can retain that heat for a very long time. It takes you can heat the steam for higher temperature. Clear? Yeah, but we are saying atmospheric pressure. Yeah, because remember, um, that's what we want to know right now. All right. So next, let's talk about sun. Okay. Now, obviously, you can see that the energy symbols. I forgot to click it on, and you can see the energy is coming on, and nothing is happening. Why? We need the right system. Yeah, correct. This is nothing is gonna happen in this case. Yeah, yeah, because this is a clock wheel. This can only convert mechanical energy, not the solar energy. Yeah, so we need to use solar panel. So let's use solar panel. Okay, now let's do the reset again. Yeah, so we understood why, and so use solar panel. This actually, the problem is that as soon as you start the solar panel, you'll have to use the pause button, because as soon as you insert the solar, there is no on and off in this particular case. You can increase the intensity of cloud, yeah, and so that will block some of the energy. So let's do that. So you can see that this is the solar energy, yellow packets. They come, some of them heat the solar panel. Okay, and so let me decrease a little bit of that cloud. Okay, so now hopefully some of these water packets will energy packets will come and hit the solar panel. They get converted into what type of energy? They get converted into electrical energy. Yeah, they get converted. There is no mechanical energy here. It gets converted into electrical energy. The rest of the things is basically same. Yeah, so you see that the electrical energy gets converted into thermal energy, starts to boil the water. Temperature remains same. You can see that the temperature is increasing very slowly in this particular case. Yeah, so solar energy getting converted into electrical energy, getting converted into um, uh, into um, uh, um, thermal energy. Okay, and that's what we use to heat the water. All right, now usually, you see that this is a pretty good system. One is usually because solar, the sun is always there, especially in the areas we live. It is a very efficient system. It's a free energy essentially. Yeah, putting the solar panels up is a little bit costly, but yeah, we can do that. Let's use a kettle again. We're gonna need a proper system for kettle. We can't use solar. We're gonna have to use clock wheel. Okay, you can heat. Oops. Yeah, you can heat. Um, you can heat the flask, and you can see the steam is coming out. Not all the energy is going to be used. Some of the energy is going to lose to the environment, or going to go into the environment, yeah, as a heat. Yeah, so this is the heat that is going off into the environment. Some of the energy gets trapped. They get converted into electrical energy, then thermal energy. Yeah, you can change the output if you want. You can use a bulb, and you'll see that it will light up. Okay, I can just play around with it and to understand how the conversions are taking place. So again, what type of energy now we should get from the bulb? Light. Yes, so can you give me the conversions? So this is pretty clear. This is mechanical energy. It's getting converted into electrical energy. What should happen next? Think about it. What is going to happen next? Vedant, light and heat in that order? No, remember that order is also important. Yeah, Jacob, Vedant, you guys are right, but the order is incorrect. Yeah, see what happens. What happened? Heat, yeah, thermal energy, yeah, and then so the fuse, and then it gets converted into light energy. So there are 4 conversions here. Yep, you see the light lighting up. Yeah, obviously there, this is for our understanding so that we can see the energy packets. That's why the energy packets are moving so slow. Usually they move much faster. Okay, very fast. Okay, all right. So that's our lab. You can also use bicycle, obviously, and determine. Let's do the reset first because um, so I have seen this kind of setup actually somewhere. That's one of the guys in US actually did this. They have a little gym in their basement. Yeah, and every member of the family goes and does a treadmill for half an hour, okay, or a bicycle for half an hour. That's their job basically. Every member has to do it, and that is connected to the system that generates the electricity for them. Okay, there are two things: they are healthy and they get free electricity. Okay, um, they also have solar panels and stuff to help them out. So what happens is that at the end of the month they actually get a check from because it's a reverse system. You put the electricity back onto the grid, so they generate so much of electricity that you put the electricity back onto the grid. And so what happens is their meter runs in the reverse direction. Okay, so their meter runs in the reverse direction. They get a check from the electricity department every month. They say they make about $400-500 a month. Okay, isn't it? Free electricity and a check at the end of the month. I think that's a very good deal. Okay, all right, so let's see what is happening here. Let's say this guy is doing so. What type of energy we have in our body? What type of energy do we store in our body? Chemical energy, correct. Okay, do you know the form of that chemical energy? In which form do we store it? You're not supposed to know it, but yeah, the final form would be ATP. That is correct, Vedant. Ashna. Yeah, we eat stuff, carbohydrates mostly, um, you know, and then those carbohydrates get absorbed. We also eat vitamins, proteins, and all kinds of stuff. We also add fat. Everything gets absorbed. The most of the energy that we get is actually from carbohydrates. Okay, not from fats, not from proteins or amino acid, but from carbohydrates. Carbohydrates basically, the wheat and grains and the rice and everything. Those are the carbohydrates that we eat. They get absorbed in the body. These are long polymer essentially. All right, they go to the liver where they are converted into glycogen. So they are first broken down into individual unit, then assembled back into a glycogen. Okay, many of these units, for example, sucrose, or sucrose is our table salt, or glucose, they are broken down into a series of steps. Okay, there are 3 or 4 cycles that is done. So you start with the glucose and eventually you break it down into carbon dioxide and water. Okay, obviously we exhale carbon dioxide, correct? And during this breakup of the glucose, let's say for example, if you're breaking down glucose, we need oxygen. Okay, so that's why we inhale oxygen. We use that oxygen to break this glucose molecule into carbon dioxide and water, and the carbon dioxide is given out. Sometimes water is also given out, vapor. We use water internally essentially. We don't actually give out water. So this breakage of carbon dioxide of glucose into carbon dioxide is done in a series of steps, and in this series of steps, in each step, not in each step, in many of these steps, some of the steps would utilize energy, some of the steps would generate energy, energy in the form of ATP, adenosine triphosphate. Yeah. um, Essentially they add a phosphate group to ADP. It's not a rocket science that happens in our body. We have a ADP, that is called adenosine diphosphate, and during this cycle you add one more phosphate. This cycle adds one more phosphate to ADP, and you get ATP, which is adenosine triphosphate, and that is the currency for our body. So you can see that in this particular case this symbol E is the currency. Okay. And you can think about, these are different countries. So if you're going from one country to another country, you need to change the currency. Yes, in our body, ATP is the energy currency. If you want to spend anything, do anything, you need to spend ATP. Okay, ATP is like a money in our body. Yeah. And it is good to waste your money. There's usually that means that your muscles and everything else is doing more exercise, getting more work done. That is a good thing. Okay, if you don't spend it, what happens? Well, you're gonna have leftover ATP. Your body is going to keep generating, so whatever you eat is going to get stored in the body as glycogen and as fat. Okay, and that's why people would get fatty. That is the, so if you spend more energy, you'll lose more fat, or you'll be in a much better shape. If you don't, then you won't. Okay, that is the idea. Okay, I personally like what this guy in US did. Yeah. I think that is a very, especially in a country like India, I think we can use a technique like this. Yeah, because especially I live in Hyderabad right now. The power situation is just horrible. We lose power. There's the power goes for about 3 to 4 times a day. Yeah, that's a bad, basically. Even in Bangalore I was before, the power situation is horrible. You cannot live without an inverter. You cannot sleep without an inverter because there is no power at many times. All right. So yeah, that's the guy with the chemical energy. It gets converted into mechanical energy. Let's play it. All right, now it'll get converted into another, so this mechanical energy will get converted into electrical energy, obviously, and then to thermal energy. So you can see the forms are much different. So I'll just crank up. Now what should happen at the end of it? You should see the bulb being used, but obviously you'll see something that is very surprising. What is happening? The guy is losing chemical energy. Yeah, it is not a source. Now you can see that this guy is almost done. Yeah, we'll stop. What do? Simple. You eat food, and he's happy now. He wants to go again. Yeah, is that clear? Okay, very good. Now we'll do another lab. So if you click on the intro tab, you come to this page. You have a water, you have an iron block, you have a brick, and you have 2 heating mantles. Okay, and you have 3 thermometers. This is all you have. So first thing first, you click on the energy symbol. Okay. Now what you should do is so you see the iron block and brick. Which has more energy from what you see? Iron. So which is going to be at higher temperature? So which is going to be at higher temperature? Are you sure about that? Yeah, so iron is going to be at higher temperature. Do you have a brick and a steel in your house? Can you check the temperature of these 2 things? You have a brick in your house, right? Somewhere you can find a brick or whatever, or any other object. You can take a book and let's say a flask, a steel flask, yeah, or you can exactly, yes, they are going to be at y. That is the that is the principle of equilibrium. Let's check it. Yeah, so you can check. What do you think? Same temperature? Yes, they are at exactly the same temperature. Yes, clear guys? Even though iron has more energy in it, that's the potential energy. Yeah, that is the stored energy. It does not mean it has higher temperature. Temperature and energy is not necessarily the same thing. Okay. Now, if we keep a brick over iron, do you see energy being transmitted from iron to brick? Usually we see that, if you have more energy from when you have more energy, it will usually have an equilibrium, correct? The amount of energy that's the way you think, uh, but here nothing is happening. There is no energy being transmitted between the iron and the brick. Okay, that's because they are the same temperature, and therefore that's their inherent amount of energy in them. Alright, so now what we'll do is, you can clearly see that water has much more energy. Yeah, water has much more energy. And if you do this, let's heat it. Okay, so we'll put it on the um, and heat it, and you can see that the energy gets transmitted into the brick. You can add more energy to the brick, you can rise the temperature. You can see that, yes, you have added more energy. And let's pause it. Alright, so we have added some energy into the brick. See, the temperature has risen. Okay, we can see that this has about seven seven energy packets, and the iron rod has 6 energy packets. Okay, so let's uh, let's see if we can lose a little bit. Yeah, so now this has 6, iron has 6. What do you think, if I keep it on the iron, what do you think is going to happen? There going to be an energy transformation? Okay, and in terms of energy packets, will there be any transfer of energy? That is correct. Jacob, Arjun, you both are correct. Heat will flow from brick to iron. That is also correct, Arjun. Now, what about the energy packets? Okay, so we understood the heat will flow. Yeah, the temperature of the iron will increase, the temperature of the brick will decrease. So we understood that the heat will flow. What would happen to the energy packets? Packets remain same. Let's try it out. Okay, let's fast forward, because this is going to take, oh sorry, actually it was paused. So make sure that you have to, whoops, what do you see? Whoops. Yeah, so I think let me pause it. So what happened? So let's, I think let's so uh, so this is actually, you cannot see the temperature on the top, so I've paused it. Yeah, so nothing is going on right now. So yeah, I think now you can see it, and I'm gonna play it now. And so what happened? Energy got transferred from the brick to the iron. So you have to think about it. You said, when you said that uh, brick temperature would decrease, you remember that what you said? You said the brick temperature would decrease and the iron temperature would increase. How in the hell is that going to happen if there is no energy flow from the brick to the iron? Yes, there must be energy flow from the brick to the iron for that to happen. If you compare the temperature of the two things now, yeah, is that same? Yes, the temperature is same. You can see that identical temperature. What do you call this kind of situation? That is correct, Arjun. They have reached an equilibrium. Alright, now at this point, if you keep them attached, even if you keep them attached, yeah, so they will essentially, both will now lose heat. Okay, both will lose energy until both the temperature comes down to room temperature. Okay, so heat is nothing but a form of energy. Yes, heat is nothing but a form of energy. Energies have different forms. We saw it had chemical, thermal, electrical energy, also potential, kinetic energy. Yeah, and so the what we had initially was the potential energy. Then we heated, added some more energy to it via heating it. That's the thermal energy we added, and you saw that now it has reached an equilibrium where both of them are at room temperature. Okay, alright, so let's do the reset. Everything clear for this? Alright, so now what we will do is again click on the energy symbols, use the iron, or use the iron brick. We'll put one thermometer. You don't actually have to, I just figured out today that you don't have to have the thermometer inside. You can have the arrow inside, that's all. Arrow must change the color, that's it. So you can see that now the arrowhead is yellow. If it changes to red, that means it is in the brick. Alright, so let's add energy to the brick. Obviously you can see that it reaches a specific temperature. We'll pause it and drop it in the water. Yeah, what is going to happen? You can see that the water temperature is rising. Yes, and the temperature of the brick fall up to a point where now they have reached an equilibrium. Okay, now at this point both water and the brick will lose temperature and be at equilibrium. Yeah, and you can see that some of the energy is being dissipated in the form of heat. Water has not reached a boiling temperature, so it is not going to boil, but it will still lose heat in the form of energy packets and will be at room temperature after maybe an hour or so. Okay, understood? Okay, very good. So we're done with the lab. Okay, we'll solve some questions now.